Hey everyone, welcome to dotnetFlix. Today our guest is Erwin Staal, and Erwin, you're going to talk about Azure Deployment Environments, right?
Yep, that's correct. We're going to talk about Azure Deployment Environments,
Cool,
and we're going to see how that's going to help to deliver your software and your infrastructure.
nice. Yeah, I haven't worked with it, so I'm pretty curious what you're going to tell us. So I would say dive right in.
All right, we'll do, we'll do. All right, so to explain the story around Azure Deployment Environments and why it might be useful for you, I want to introduce you to a pizza company, the Tomato Pizza delivery company. And like many companies, during the Corona pandemic, their number of orders of pizzas skyrocket. Before the Corona pandemic, they were kind of small organization, um, but in the pandemic they grew massively. And like it goes with many organizations, also for this one goes that growth didn't really go as easy as they would have hoped. So pretty early on in the pandemic, they had this monolithic application, and it simply couldn't cope with the load and the number of orders that were placed in the system. So, like every company these days, they decided to go full blown and go all in on microservices. So you see a few of these microservices here, which probably make kind of sense for a pizza delivering company. And so with going in on microservices, they also went full in on the DevOps practices. At least they tried. So each microservices is managed by a different DevOps team. But a problem that they still have, which we see in many organizations, is that they do build and deliver their software, the microservices, as teams individually. But the infrastructure is still provisioned to them by a central IT organization. And as you can imagine, that's far from ideal. So there's a few problems with this approach, and there's also a few reasons actually why this pizza delivery company still does it this way. So let's look at a few of these problems from both sides, from both angles. So if you look at the DevOps teams that obviously need the infrastructure in the Azure cloud, the problem is that some of these teams, actually most of the teams within this organization, they lack the skills to actually deploy and properly configure a secured infrastructure. So with microservices, etc., that's all pretty cool, but it's all quite complex to deploy a microservices environment into the Azure cloud. It's not just a container, it's all the other services around it. It's identity, it's security, it's networking, all those type of things. So some of the teams simply lack the knowledge to be able to end-to-end deliver their platform. So they rely on the central IT team to get the infrastructure up and running. Um, but there's no self-service enablement from that central IT organization. So if they need a change to their infrastructure or when they want something new, they need to request that with the central IT organization through a ticket. And as you can imagine, this IT organization still does things manually. So there's pretty long waiting times to actually get some new infrastructure out of the door and into the Azure cloud in production. So that's a few of the problems that the DevOps teams building these microservices run into on a daily basis. But the central IT team also has a few problems because they actually do want to help these DevOps teams to deliver this infrastructure pretty quickly. Um, but they also don't really want to give these teams who could and who would actually have the knowledge. They don't want to provision or provide the keys to the kingdom to these teams because they are quite scared what might happen in production in the cloud. They're mostly scared of security and compliance risks, which they now manage centrally. They also feel that if you just let each team do whatever they want, that you cannot fully optimize for resource allocation and utilization, which in turn might cost you more money than you actually want to. So how do you actually keep costs under control when everyone can actually just deploy their stuff to the cloud, not in a central manner? They don't really understand how to do that. And last but not least, they also think that when they do it as a central team, that they can actually better do things like standardization and collaboration. So although they see the need, they also find it hard to actually get it into place. But then again, they also understand that that's not really what we meant with going to the cloud, right? the cloud has this promise of elasticity and being able to quickly spin up whatever you need, be able to play around with new infrastructure, etc. So they understand that they need to be able to deliver new infrastructure to their development teams in a fast and hopefully self-service way. And they also understand that they need to put everything in place on the infrastructure and tools and whatnot to get that developer going and make the developers as efficient as they can. But I still want to do that in a governed way. So still pay attention to obviously security, compliance, and cost control. And then this developer from that central team went to a conference, came back, and at that conference he heard about platform engineering, and he also heard that Gartner expects that around 80% of the engineering organizations to have a team dedicated to platform engineering in just a couple of years. So he came back and said, we also need to get this going. We need to go that way. And so with platform engineering, what organizations then tend to do is have a central team that manages the stuff that all other DevOps teams need. So, and by doing that, they can enable developer velocity, accelerate it. They can increase the impact of DevOps teams because DevOps teams don't need to worry anymore about the underlying platform, for example, piece of networking, that kind of stuff. That's done by a platform team. And they can also improve overall security by doing that. But the big thing is that all these things and the whole platform engineering approach is built around these self-service mechanisms, not being in the way of teams through tickets, etc. No, you want to enable teams to do to automatically provision infrastructure, for example, through self-service portals, etc. So this engineer went out to Azure and found that there's actually a product in the Azure cloud that can help you do these type of things, which is Azure Deployment Environments. So the tagline of the product is accelerate the DevOps lifecycle with on-demand pre-configured environments. So it's a product in the Azure cloud, which allows developers to provision infrastructure, which is configured by the platform engineering teams. So there's this real separation between these two roles in this particular product. So if we first look at the developers, then this product offers a few ways to deploy new infrastructure, easy and on demand through self-service. So the screenshot that you see on the right is the portal that a developer can go to and request a new environment, which is then instantly provisioned. But they can also use the CLI or a CI/CD pipeline, which we will also see later on in demos. And then the platform team, they can actually build and write the infrastructure as code templates, which then in turn obviously deploy these infrastructure. And when a developer wants to request a new environment, they can go to some library and find the definitions of infrastructure that are available in the tool for the developer to deploy, which has been created by the platform engineer. And the same platform team can also set up what we call environment types, which in turn can then be used by the developers to deploy an environment. So the screenshot that you see here is an example of a test environment type. And as you can see, we can control all sorts of things on the environment, which a developer then later on does not need to do anymore. So for example, an administrator or someone from the platform engineering team can dictate that an environment of type test needs to go to subscription A, and he can arrange which identity is used for deployment, etc. So all those things that a developer normally needed to do and needed permissions, etc., that's no longer needed and can be administered by the platform team. And last but not least, there's also some management capabilities in the tool to view environments, track cost, and all those sort of things.
Erwin, I've got a question. So this looks really, really interesting to me because at the moment I'm working with a couple of clients who want to go to platform engineering and do establish a platform team. So with Azure Deployment Environments, right? So in your example, the team can use this to deploy, let's say, the basket servers to a test environment or to production. Can they also create this to create new microservices, so that they set up, they basically choose a template. Like I want to create a .NET microservice that uses a SQL Server. Is it also meant for that?
Well, in the sense that we will later also look at the templates, but the templates and this list that you see here, the account microservice, for example, the templates behind that account microservice, if I remember correctly, it deploys an app service, it deploys application insight, it deploys a SQL Server, a storage account, and whatnot, which developers then can use to deploy their application on top of.
Right.
So and these infrastructure is managed in templates. For now, that's Bicep. So that's the way how that's been written and then provisioned through the tool. Yeah.
Okay. So, yeah. So as a platform engineer, I could create a template that says like, hey, create a microservice with SQL Server, and then I have some Bicep scripts in the back which spin up the app services or the container apps environment and SQL Server, and then I can give that option to my developers. They use the template and then they deploy their software on top of that.
Yep. Yeah. We will see later on in the demo that a developer can go to a portal and deploy it, but you can also use it in a GitHub action, for example, as we will see in a bit. So that when you create a pull request, you actually spin up a new environment, which is based on these definitions, cool. And then whatever you change in your pull request is deployed on top of that infrastructure, and you can test it right away in your pull request.
Right.
So there's a few ways that you can actually use to then provision the infrastructure. Yeah.
And Erwin, normally you also have, for instance, Azure policies, right? So that you can use to prevent people from deploying certain resources and configuring certain stuff. Is that also part of these templates, that you can only deploy what is defined or what is allowed by the Azure policies, or is that something separate from the deployment environments?
Yeah, it's separate in a sense that is not in this product. But if you have policies enabled on a subscription, for example, and try to deploy something in that subscription, then policies still apply.
Okay.
So it's a separate thing. But the ones who write these templates, which then tend to be the platform engineers, they still need to adhere to the policies because the policies still apply.
Yeah, that makes sense. Okay, thanks.
All right. Before we jump in a demo, Azure Deployment Environments is part of what we call Azure Dev Center, which is an offering in the Azure Cloud. And the Azure Dev Center might also be known to you because of the fact that Microsoft Dev Boxes are also part of the same Dev Center. So these are the VMs that you can spin up for developers and allow developers to do their work in those Dev Boxes instead of their local machines, etc. And so you can give them a development machine in the cloud through Microsoft Dev Boxes. You might know Codespaces. Codespaces are, well, there's a few more differences, but Codespaces is mostly built on Linux, and Dev Boxes are built on Microsoft Windows. So it's often a choice to go to Dev Boxes. But it lives in the same environment, Dev Center, and it also utilizes some underlying techniques, etc., from Dev Center. All right, so before we move into the demo, let's have a quick look at how the product is actually being used by the different roles that we talked about, the platform engineers and the developers. So the platform engineers, they tend to write the infrastructure as code templates and make them available in Azure Deployment Environments. Here is the platform engineers, but you can obviously also imagine that when a DevOps team is a bit more mature, you can obviously allow them to also change the infrastructure templates and make modification or make new ones. As you will see later, it's done through Git repos, etc. Just in a normal way, but as you would probably expect. But next to the templates, the platform engineers can also do what we call the environment type mappings. So they can configure which users are allowed to deploy which environments to which subscriptions, which identities need to be used while deploying, and set permissions. So when an environment is deployed, who can access that environment? And we can also manage, obviously, some stuff through secrets. So when the platform engineer is done with configuring the product, it's then up to the developers to actually provision the environments. And they can do that in a few ways. There's the manual approach. So there's a dev portal, the devportal.microsoft.com, that you can go to, and there's a UI, as you will see in a bit. You can use that UI to provision an environment. And there's also a CLI tool, so you can also use your CLI locally to deploy a new environment. But you can also use the same tool in, like we just mentioned earlier, in a GitOps flow. So you can also use Azure DevOps or GitHub Actions to provision these environments. Like I just gave the example, you create a pull request, and while creating a pull request, a new environment is spun up. Your changes are deployed, your software changes are deployed on top of that environment. And while doing your pull request, your test engineer, for example, or whoever reviews your pull request, can go out to a live environment and see if it actually works and works as expected. All right, so Dev Center is built up in a few components, and we'll quickly go through them before we dive in. So first of all, Dev Center has the notion of catalogs, and catalogs are basically the environments, the infrastructure that you allow your engineers to deploy. So the templates, etc., those are in the catalogs. You can configure identities, which are used to actually deploy the infrastructure. We have the notion of environment types, which mostly refer to things like dev, test, production. And we can set, for example, tags on them, so that whenever an environment of type test is being deployed, there's also tags being applied right away. And then probably the most important part is projects. So the Dev Center, you mostly have just a single Dev Center for your whole organization. And then you have projects mostly per team. So within the project, that's where you configure your team specific stuff. So that means permissions, which team members get what permissions on the infrastructure. Also the environment settings. So if this team deploys infrastructure, to which subscription do we do that? Those type of stuff. And also again, identities. Here we can again also leverage separate identities to do the deployments to the dev environment than to the test environment, for example. Those can be separate identities. All right, let's go on to the Azure portal and dive right in. What we're going to do is we're going to start within my Dev Center because there's a few settings that you configure once on a global level in the Dev Center. One of the most important ones is probably the catalog. So the catalog is your templates, the infrastructure that can actually be deployed. And as you see, catalogs are basically nothing more than a reference to a GitHub repository, either in a Git repository, either in GitHub or in Azure DevOps. So as you can see, my repository, my catalog here refers to my repository in GitHub. And you set up a connection by creating a personal access token, which you need to store in a key vault. And then your catalog is linked. And update, unfortunately, doesn't happen automatically yet. So when you do make a change to your infrastructure, you need to hit the sync button over here. So it syncs your infrastructure in your repository with your definitions here in Azure Dev Center. That's something that's on the roadmap, but it's not there yet. So another thing is, like you already mentioned, the environment types. And an environment type, for now at least, has nothing more than tags. So we can say dev environment has a particular tag, and when an environment of this type is then being created, that tag is automatically applied. But these environments, we'll come back to them when we configure the actual product. But before we do that, and before I forget, obviously, let's first actually have a look at the infrastructure that now resides in my catalog. And let's have a look at what that actually looks like. So we move over to VS Code, in which I have my repository open. And this folder here is the folder in which my infrastructure resides. So this environments folder here is the folder path that's mentioned here in the catalog. And each different piece of infrastructure that you want to enable to be deployed should reside in a subfolder of your root. And so as you can see, there's a few, I've defined a few. And we're going to look at the inventory microservice here. Each of these infrastructures, the definitions, they have this YAML, this manifest file, in which you describe the infrastructure that an engineer can actually deploy. So it has a name, a version, a summary, those type of things. An interesting thing is it also has a runner, which is currently set to ARM. And that is because the only way to define infrastructure today is through ARM templates. Terraform and even Pulumi are on the roadmap, but today it's just ARM templates. So that's also why in this template path we reference an Azure deploy.json, because that's an ARM template. What you can obviously do, and what I've done in this example, is you can obviously write your infrastructure in Bicep, then transpel that Bicep to an ARM template and have that actually deployed. So you can still manage your infrastructure in Bicep, but you have to do this extra step of converting that into an ARM template before it's usable in deployment environments. And there's actually a private preview going on for Terraform right now. So hopefully it's not going to be too long before that also pops up. And I can also imagine that for Microsoft, it shouldn't be too hard to accept Bicep and do that transpilation to ARM templates themselves. So I can also imagine that that's going to come in pretty soon.
Yeah, that would definitely make sense.
Yeah, I truly don't understand why that's not in place anyway. I mean, yeah, they can do the convert themselves, right? It would be that feels kind of logical to me, but who am I? So last but not least, here in this file is the parameters that you can also define, and these are then the parameters that a user will see in the portal, for example, when they want to deploy this particular environment. So it has a name, description, type, those type of things. And then the actual infrastructure is just regular Bicep code as you would expect. And this particular inventory microservice, it has application inside. It deploys on a function app. So it has a server farm, the application plan. It has a storage account. Just the things that you would normally do in a Bicep template to get some infrastructure going. So nothing new, nothing different here. It's just regular Bicep that you can use to get this going.
Erwin, a question?
Sure.
So in this case, it's a single microservice that, for instance, deploys a storage account. But if you have a storage account that you might, for instance, share among multiple microservices, is that also a concept that's supported by deployment environments or not?
Yeah, in the sense that it's just infrastructure, right? So
Okay.
it would require you to just create a different folder with a template inside of it, and that deploys the shared storage account, which you then can use in other pieces of infrastructure. Yeah, and can refer to that. Yeah.
Cool.
I would question the autonomy of your microservice, though, Edwin, but
that's a different discussion.
But that's a whole different episode, I guess.
We also talked about cost control, so let's see where it lands.
Yeah, but I do agree. You probably need to have a different discussion when those type of questions pop up. But yeah. All right. So that's the catalog and how you actually do, create your infrastructure and get it up in here. So let's then go a level deeper and have a look at a project. I provisioned one, at least. Yep, there we are. And on a project, there's again a few things that we can set specifically for this project. And as I mentioned earlier, there's most likely to be a project per team. So what we can do here is go to the environment types and configure what types of environments this particular team can actually deploy. So again, I have the dev, test, and prod environment type. Those are linked to the environment types that we saw earlier on the dev center level. And I can actually edit this one and configure a few interesting options. So first of all, I can configure the subscription that should be used when someone from this team deploys the dev environment. So the dev environment goes to the Tomato development environment, whereas in production, you would obviously use a different subscription. We can choose the identity that's being used to deploy this environment. And this time I've chosen to just use the managed identity, the system assigned identity, but you can also pick your own. And it's important here to note that whoever triggers the deployment, that's not the one, not the identity at least, that actually does the deployment. So we will see later that you can actually deploy infrastructure from a portal. If I do that, I'm not the one underwater who actually deploys the infrastructure. That is this particular identity. So there's a separation between who triggers the deployment and the identity that actually does the deployment. But then again, when the infrastructure is created, I can specify what access needs to be granted to the one who provisioned the infrastructure. So that could, for example, be contributor. And I can also provide additional access. So for example, I can say that I have a group in Active Directory, Entra ID, sorry. I can say that the engineering group should also be secret, key vault secret officer, and my test engineer group should become reader on this infrastructure. So you can do a lot of set additional permissions here to make these environments work. And again, you can also set a bit of additional tags, which might be handy for cost optimization, those kind of things. All right. And last but not least, what we can also do here on the project is actually see which environments have already been deployed using this project definition. So as you can see, there's a few project pieces of infrastructure being deployed through this project. We can see if it actually succeeded. We can see in which resource group that environment was deployed. We can see if there's actually advisor recommendations in Azure, and you can also view the costs. If you click on view cost, you will actually be routed to the resource group in Azure to the cost blade on that resource group. I sort of hope that they later on just show the actual cost here instead of me having to go into the resource group. But yeah, well, that's what it is. That's what it is for now. So with that being said, we've now seen how the platform engineer does his job to set up the environment and allow developers to actually create an environment. So let's see how that actually works. So what we're going to do, we're going to look at these two flows. We're going to see how a developer can manually create environments. And then later on, we're going to see how you can also automate stuff through GitHub Actions and why that might be useful. So first of all, let's go to that portal that I mentioned. Yes, there we are. All right, so let's zoom in a bit. So this is the dev portal, devportal.microsoft.com, through which an engineer can then provision an environment. So you can go here and create new environments, or you can actually see the environments that you already own or your team actually owns. And you can see what runs, you can see the types of these environments, you can see who the owner of an environment is. And you can also set expiration on an environment, so it's automatically deleted afterwards. So this environment is going to be deleted in 21 hours. So in terms of cost saving, that's a nice feature, which actually added, I think, a month ago or something.
Well, what kind of expirations can you set? Do you always have to set like a amount of time, or can you say, hey, when the weekend starts, shut down everything?
Oh no, you actually need to. Well, you can actually see, because let's provision a new environment, which is done through this new environment button over here, and then the expiration is set down here. And what we can do is we can select a date, so we can say I want this one to be deleted tomorrow, and we can set a time, so delete it at 3 o'clock or something tomorrow.
Cool, useful.
Yeah, that's really useful in terms of cost control and etc. That's really cool. So what you do when creating an environment, you give it a name. And then we get to select the infrastructure type that we want to deploy. So we're going to do dev, and we need to select the infrastructure definition that we want to deploy. These basically mimic the folders that we just saw in my Git repository. And if we click here, you can see all the definitions that I have available, and then you can also see the description, for example. You can't, I was kind of hoping that you could also go into the template and see what is actually being provisioned, but that's not the case. You can't click on it and actually dive into the template. I was kind of hoping that that would happen. Maybe that will come later, and nice visualization of the infrastructure, whatever. But not for now. So we select the inventory microservice. We hit next, and then there's a few other parameters, and these are the parameters that we saw in the YAML definition just a few minutes ago. So these are the parameters that go into the infrastructure and are needed to deploy that. And if I then hit create, it's actually gonna start provisioning that infrastructure, as we can see down here. So it's gonna take a while. It needs to provision stuff. It needs to assign a few permissions, which takes a bit of time, etc. So we're not gonna wait for that to fully be provisioned. But that's how you can go to this portal, provision an environment. And you can actually also redeploy an environment, change its exploration, or actually delete an environment right away if you want to. And as you can see here, this one was created manually again by me, so I'm the owner of this environment. But these two were created by my pipeline, my GitHub Actions pipeline. So then the identity of that pipeline is actually the owner of the environment. So that's the reason for the difference there. If we now go back to the portal here and we hit refresh, then we should see that a new environment actually pops up, and you can see that it starts preparing to deploy this new environment. All right, so that's how a developer or an engineer can actually go into this portal and manually create an environment. So before we wrap up, let's also see how this tool can help you in workflows and the GitHub Actions, etc. So what you can do, for example, which I've done in this demo, is I've created a few workflows which can create an environment, delete an environment, update an environment. And whenever I now create a new branch on a repository, it's gonna, and I push that to Git, then it's gonna create a new environment based off my branch. So let's have a look if this was actually one of them. Yeah. So what the pipeline does is it obviously does the standard thing. It builds my application, which is an API. It installs the CLI, the CLI for Dev Center, and then it starts creating the environment. And creating the environment is basically then nothing more than running an Azure CLI command, which then talks to Azure Deployment Environments and provisions my environment. So it passes around a few parameters, and the environment will be provisioned. Then, when the environment, so the infrastructure is spun up, my pipeline will then deploy my application, my API. And when we go back one step, then in the result, you will see that it will post the details of the environment that we had just deployed. So I can actually go right-click to the URL of my API, and if it starts up, if it doesn't take too long, then you actually see that my API is running, which is a very simple API here in this example. It just returns a few date times in different time zones. So nothing fancy here, but you can probably see what you can do. You can create a branch for your work, push your change, and your changes are automatically being deployed on a fully separate, isolated environment for you to work on. And every time when you do a commit and push the commit, that's actually being updated on this environment. So you always have a live environment with just your changes in isolation. That might come in very handy to do your work. Another thing that you can do is obviously incorporate that same way of working in a pull request. So you do a pull request, and while the pull request is going, you also trigger an action, and that wasn't kind of what I was expecting. Let's go to this one then. So this is basically doing the same thing. When I create a pull request, it will again trigger a pipeline, and it will again create an environment, but this time of type test instead of type dev, which I do on a branch. So it's going to provision a test environment, deploy my changes, etc. And then in the pull request, it will, as a comment on the pull request, again tell in which resource group that infrastructure lives, and also again it will give me a link to the actual environment deployed in Azure DevOps. So if someone who would review this pull request could go to the URL and see what actually works and do a few tests and whatever, or a test engineer or whoever actually looks at the this environment. And these things.
Is it possible, Erwin, to let's say you and I are working on the same project and we both create a pull request? Is it possible to get a test environment for our own each?
That's actually what this is doing. Yeah, it will create a. You can actually also see it a bit by their names.
Yeah, so that was my next question. What does it do about naming collisions?
Yeah, it actually uses. I guess this identifier over here is probably some identifier of my GitHub action run or something.
Right.
And the same here. You can see this is based off a branch, and this is a PR. So this is the one that belongs to my pull request, and this is my dev environment, which belongs to my my branch. So it will create a hopefully a non-colliding environment for each developer.
Yeah.
And you should get your own environment for each.
And it uses that same postfix for your Azure resource names, I guess, because I also see that's used in the resource group name. Yeah.
Yep. It uses it all the way through. So you also see it in the name of your app service plan, in your function app, in your storage account, those kind of things. Yeah.
Cool.
So it's already relatable back to the name of your branch, etc. Yep. And like I was saying, you could obviously always do these type of things, right? Deploy infrastructure while doing a pull request or whatever. But it's the thing that it now comes from a central place, and whoever does the deployment, from which angle, if it's the portal, if it's a PR pipeline, if it's the pipeline to production, we can all use the exact same tools to deploy the environment and use the exact same underlying templates to do these deployments. And I think that's really nice that we can leverage all these tools and deploy that into these secure and compliant environments set up by the platform engineers. So with that was what I wanted to discuss with you guys today.
Cool.
Yeah.
Yeah, great. Thanks so much. Really super nice. Looks really useful. So I'm not sure if I missed it, but I had a question around the ARM templates. Can you both deploy them at subscription scope as well as resource group scope?
No, that's a good question. No, you cannot. It's currently it's only deployments in a resource group, because the resource group itself is actually created by the tool and not by my template.
Okay.
So that's indeed can sometimes actually be a limitation, that you need to work with a single resource group instead of deploying your infrastructure into multiple resource groups.
Yeah. So if I definitely want something in multiple resource groups, then I just have to create different environments and deploy both of them.
That's at least how that would normally work for now. I do wonder, there might actually be ways to I haven't checked, but probably to come around that. I mean, you can obviously target your bicep code at least at a subscription level, and I can imagine that the thing is deploying an ARM template, but it's deploying it to a specific resource group. So I would be curious to see what actually does if you create a template which deploys subscription level stuff. But it might just fail because it tries to deploy it into that resource group, and it probably then you might not be able to step out of that.
Right. Yeah, maybe once they support Bicep, they also have support for subscription level stuff. Right.
It would be nice if you can actually choose to create that particular resource group yourself, or then multiple. Yeah.
Yeah. All right. So Erwin, again, thanks you so much. This was really interesting and really topical for me. So for those watching, please like the video, subscribe to our channel. It really helps us out. And we'll see you at the next episode.
All right.